The power rule, this is probably the most important rule out of the three for solving equations, although the other two come in handy as well. The power rule says this. If you have the log base a of, let's say, m to the c power. So the input on the log function is m to the c power. Turns out that's equal to log base a of m times c. So we could actually put the c out in front so it doesn't look like mc is your input. In other words, it looks like we can pull this guy down in front. It's another strange looking property and make it a factor. So log base a of m to the power of c is equal to c times log base a of m. Notice what's happening here. With the product rule, we reduced a product to a sum, right? With the quotient rule, we reduced a quotient to a difference, a subtraction problem. And with the power rule, we're changing a power, something with a power in it, to something with a product in it, c times log base a of m. But it's not that big of a mystery where the power rule comes from. Think about it. Let's say, for example, we have log base a of m cubed to kind of grab a hold of a specific exponent. Then really, what that says is we can bring the 3 down in front and write it as 3 times log base a of m. And the reason why you can understand that in terms of the product rule is if you think about m cubed, what does it really mean? It's log of m times m times m. Because there's two products in there, all we have to do is apply the product rule twice and add like terms, and we'll see where that 3 comes from in front. So think about it. If you apply the product rule to, let's take m times the m squared, m times m. If you apply it there, you get log base a of m plus log base a of m times m, or m squared. And then if you apply it one more time here, you still have this log base a of m out in front, plus this guy becomes log base a of m plus log base a of m again. Just applying the product rule twice, we get that. Now these guys are all like terms. We have 1 times log base a of m here, one of them here, one of them here. You've got how many of them all together? 3. So we get the power rule by repeated application of the product rule. How would you rewrite log base b of x to the 10th as a product? In other words, let's make the input just x and rewrite this as a product. What do? What does the power rule say this is equal to? Yep, it's as simple as that. You just bring the 10 down in front and make it a factor. So log base b of x to the 10th is 10 times log base b of x. Could you go the other way with the power rule? How could you rewrite as a single logarithm? So this is 20 times the logarithm base a of x. How could you write that as a single logarithm? According to the power rule, what could you do with the 20 going the other way? You could, well, don't use the word add. How about make it the exponent on the x, right? Yeah, I knew what you meant, but we got to be careful. So 20 times log base a of x is equal to log base a of x to the 20th power. So the input is x to the 20th.